We will proceed in the story of gradient vector, that where gradient vector is useful and it is something like no one can replace it. Gradient vector is something that is so useful that no one can replace it. It is amazingly useful. So where gradient vector, it's not simple derivative. If you see simple derivative, if you see simple derivative, then it is called gradient. Like if I have a like if I have a circle and at this point if I calculate simple derivative, then it is a straight line. Simple derivative is a straight line. Whereas if I go with the gradient vector, gradient of position vector, little bit different. If I have a circle equation, if I have a circle equation, then each point in the circle, if it is centered at the origin, then each point in the circle can be represented through vector, where vector one end is at center, and this is called position vector. If I have a position vector, then its gradient is perpendicular to this position vector. If this is position vector, then perpendicular is like this. Then it becomes a tangential vector, not the line. So if I have a gradient, if I have algebraic equation, and for that algebraic equation, what is the algebraic equation of circle? X square plus y square equal to a square. X square plus y square equal to a square. That is the equation of the circle. So if we calculate this equation is of no use for the calculus perspective. If I have a circle x square plus y square equal to a square, from calculus perspective, what is fx? Then it is y equal to a square root of a square minus x square. What is its gradient? Dy by dx. Then gradient is minus x divided by square root of a square minus x square. That gradient dy by dx is nothing but if I replace x with any x point, x is 1, 2, 3, 4, whatever, at that point, if I see, then it will be tangential line. But gradient is a vector. Gradient is a vector. If it is a vector, then it has nomenclature, it has the power of a vector. That is, it has a magnitude. If it is a vector, then it has a magnitude and it has a direction. So if this is position vector, then this is gradient vector. If this is gradient vector, then gradient vector's gradient is again opposite to the position vector. If this is going towards center, if this is the gradient's gradient vector, then its gradient is again tangent perpendicular to it, but it is this direction. So every time you calculate the gradient, it becomes perpendicular to it. What is gradient vector of a algebraic equation? If this is algebraic equation of a circle, then its gradient vector is perpendicular to the it. If this is position vector, then gradient vector is perpendicular to it. So gradient is always perpendicular. So that is the scenario. So if I take algebraic equation of a circle, then gradient vector is radial. If I convert this algebraic equation into position vector, then gradient vector is perpendicular to it, that is tangential. We are talking about position vector. If I have a position vector of any curve or surface, then its gradient vector is tangential to it. But problem is that gradient vector is one more derivative. If derivative comes into the picture, then it is called velocity vector or gradient vector or vector field. So if I have position vector p, then dp by dx is velocity vector. If dp by dx is velocity vector, then it is a gradient vector. Now, velocity vector is along the curve. Can you see it? Everywhere it is tangential means it is along the curve. Tangential means it is moving as per the curve. If I calculate the magnitude, then it will give me the curve length, but it is a velocity vector. So if I calculate magnitude, then it is velocity magnitude. If I want this distance, then I have to do one integration, because integration of velocity results in collection distance. Differentiation of distance results in velocity. So I have to do integration. This is the formula that we are using it, and we have proved that the curve length of the circle is 2 pi r. We have done it. Not only that, we tried parabola also, and we found the length of a line. That much. Okay, we can do everything. Now science is coming that can we calculate surface area of a sphere? Surface area of a sphere. Okay, I really have a sphere. So this is a sphere. What is the surface area of the sphere? We started the discussion that surface area of a sphere is nothing but what is the length of a curve. If you have a position vector, find the gradient vector. If you have the gradient vector, calculate the magnitude and then integrate it. So gradient vector is, if position vector is displacement vector, then gradient vector, if position vector if position vector is displacement vector, then gradient vector is velocity vector. So for this sphere, if I calculate position vector for this sphere, if I calculate position vector, then its derivative, its gradient vector is velocity vector. If I calculate the magnitude and do the integration, I'll get the surface length, surface surface area. Simple, right? But if I have a position vector, then derivation, the gradient what we are calculating, it should be have, there are, if it is 3D, if it is 3D, then there are three coordinates coming into the picture: x-axis, y-axis, and z-axis. X-axis, y-axis, and z-axis. So x-axis, y-axis are independent and z-axis is dependent. If that is the case, then but in earlier case of the curve length, independent component was 1 and dependent component was 1. Y-axis being dependent and x-axis being independent. Here also dependent component is z-axis fxy, but independent components are two, x-axis and y-axis. We call it independent component is one, that is xy plane. Okay, so if I have xy plane, and if I take set of points, if I take set of points on xy plane, for those set of points, if I calculate algebraic point in z axis, take some set of point x comma y, for that calculate the points in z axis. If you if you draw a surface, then it becomes a ball. What is the equation for it? That is square root of a square minus x square minus y square. You take a square is the radius, consider radius is 2, then a square is 4. Consider at point x and y is 0 0, then 2. So at origin the height is 2. Consider x as 1 and y as 1. Then 4 minus 1 minus 1, 2. Then at x equal to 1 and y equal to x equal to 1 and y equal to 1, this point, corner point. So at this corner point, the height is the square root of 2. Okay, if you take all the xy and take the height points, if you combine all those, it becomes a ball. That is the equation. So z equal to square root of a square minus x square minus y square, or someone can call it z square equal to a square minus x square minus y square, or x square plus y square plus z square equal to a square. If that is the case, then this is called algebraic equation of a sphere, whereas from independent and dependent component, then dependent component being z or fxy equal to square root of a square minus x square minus y square, where x and y are two independent components. Okay. Now, can we calculate in earlier case that was a circle? Earlier case that was a circle. Earlier case that was a circle. If earlier case was a circle, then we did the gradient with respect to x-axis. Now we will calculate gradient with respect to xy plane. So I have any position vector p on the ball. Okay, if this ball is centered at the origin, from origin we have discussed it already. So if it is centered at the origin, from origin, if I take this origin, if I take this radius, then radius hits the ball and goes away. That point from center, if you draw this line, it hits the ball at some point and it moves out. That point is P, and the coordinate of P is x comma y comma z. Then it is vector xi plus yj plus zk, that is a position vector. That is xi plus yj plus square root of a square minus x square minus y square k. Now this position vector xi plus yj plus zk, I have to differentiate it with xy plane. Then whatever I get, that becomes a velocity vector, a velocity surface vector, because I am differentiating with a surface xy plane. So it becomes velocity surface vector. If I calculate the magnitude, the velocity surface vector will be everywhere. It will be tangent. It is a surface now. Surface. Everywhere it will be tangent at any point P. If it is a tangent, then it is representing the surface. If it is representing the surface of the sphere, then calculating the magnitude of the velocity surface vector and then integrating along the xy plane. We are doing everything with plane only. So xy plane representing independent component x and y. If that is the case, then we get the surface area. We have talked about it. So to calculate the differentiation along xy plane, first we calculate partial derivative along x-axis, partial derivative along y-axis. If this is x-axis partial derivative, it is y-axis partial derivative. These are two vectors. If I do cross product of two vectors, if this is there are two vectors, this is one vector, this is another vector. If I do cross product of these two vectors, it gives me area in between them. So area in between them is nothing. So cross product of parallel lines vector are 0. But as we go along, it is forming an area. And now if I calculate cross product of these two, then it will give area of the parallelogram what it is making. If I move ahead and then if I make it perpendicular, then it will give me, cross product will give me rectangular area, that is the maximum. So we are trying to, xy plane is rectangular area between x-axis and y-axis, whatever. If this is dz by dx, that is partial derivative along x-axis, and it is dz by dy, partial derivative along y-axis, then anyway I and j both are orthogonal components. So I have to calculate cross product of these two so that we can get the partial, we can get. So we want dz by, we want dp, I'm sorry. So if I have a position vector at any point P and xi plus yj plus zk, P equal to xi plus yj plus zk, What is dp by dxy plane? That is under question. That will be velocity surface vector. This is velocity surface vector tangent at the surface. dp by dxy plane. To get the dp by dxy plane, if I calculate dp by dx partial derivative along x-axis, dp by dy partial derivative along y-axis, if I do cross product dp by dx cross dp by dy, then it will give me kind of full xy plane. So dp by dx cross dp by dy is nothing but dp by xy plane. This is what we want. So dp by dx is nothing but I plus dz by dx k. J is gone. dp by dy is j plus dz by dy k. If I do cross product, then I first I'll try I with j, then it becomes k. I with dz by dy k, it becomes minus dz by dy j. Then dz by dx k with j, it becomes minus dz by dx I, and k gone. So cross product is dp by dx cross dp by dy becomes dz minus dz by dxi minus dz by dyj plus k. Magnitude of this velocity surface vector would be dz by dx whole square plus dz by dy whole square plus 1 whole square root. Now this one I have to do integration along the xy plane. Everything is one independent plane. If that is the case, then dz by dz, what is dz? What is z? That is square root of x square minus a square minus x square minus y square. So dz by dx is minus x divided by square root of a square minus x square minus y square. Then full story, that is dz by dx whole square plus dz by dy whole square plus 1 square root, that becomes x square plus y square plus a square minus x square, or rather simple form, x square by a square minus x square minus y square plus y square divided by a square minus x square minus y square plus 1 square root. That would become a by square root of a square minus x square minus y square. This is velocity surface area magnitude. I have to integrate it along the xy plane, that is dA, integration dA. So integration of a by square root of a square minus x square minus y square dA. If we go with the dA, then dA is the xy plane. So if I go in Cartesian coordinate, then xy plane dA is dx dy. So what we did earlier is we transformed it. We went with a kind of hybrid model, and dA we transformed into polar coordinate system. So dA xy plane in the small area dA in polar coordinate system become r d theta dr. So this is what we did, but we will try in Cartesian coordinate system only. Then we will move it to a spherical coordinate system also. We are not running away. So if we try in Cartesian coordinate system itself, that is a by square root of a square minus x square minus y square and dx dy, and if I go with double integration, then minus a to a. So if this is the ball, this is centered at the origin, then equatorial, here it is x-axis, equatorial, here it is y-axis at the center of the ball. If that is the case, then half a hemisphere above the xy plane story is going on, because Cartesian coordinate system begins from the origin only. So origin is at the xy plane, then xy what we are taking in the upper hemisphere only. Now the limit of x is minus, if this pierce through the ball, then minus a to a and minus a to a. That is the limit for the x and y. Now we have a by square root of a square minus x square minus y square dx dy. Limit of x is minus a to a and limit of y is minus a to a. Consider, now if you see closely, then a by square root of a square minus x square minus y square. A square minus y square is constant if I integrating through x1. So can I consider x equal to square root of a square minus y square cos theta? X equal to square root of a square minus y square cos theta. If square root of a square minus y square is constant, it is something like I have a radius, I have a radius, I if I have a radius, then if I have an angle with it along the x-axis, if this is the situation, if there is a radial and there is angle theta along the x-axis, then the x component is radius cos theta. If x equal to a square root of a square minus y square cos theta, it looks like that this is a square root of a square minus y square is a radius, that cos theta is the x component. If that is the case, it is a x component. If that is the case, then dx equal to square root of a square minus y square minus sine theta d theta. Okay. So now I have equation turned into a by square root of a square minus x square minus y square. So a square minus y square minus x square. So x square becomes a square minus y square cos square theta. Then square root of a square minus y square would come out. Okay, and inside it remains 1 minus square root of 1 minus cos square theta, that becomes sine theta. So now it is a by square root of a square minus y square into sine theta, and above it dx is replaced by minus a square root of a square minus y square sine theta d theta. So square root gone, and sine theta gone, minus a I can keep outside now. So double integration of d theta dy. So integration of d theta is theta. Now please concentrate. Now if I have x, if this is x axis in the ball, if it is x axis, then it is origin, then a is minus a to a. This is xy plane. If this is xy plane and this is origin and this is ball centered at xy plane, then x axis is minus a radius to a. If that is the case, I have taken x equal to square root of a square minus y square cos theta. This angle starts from 0 and it goes till pi. Starts from 0 and it goes till pi. We will try. So theta now 0 to pi. So 0 is 0, pi means minus pi. So minus minus gone, it becomes pi a. Pi a. Now integration of y is dy is y. Y from minus a to a means 2a. So it becomes 2 pi a square. 2 pi a square for the top hemisphere. Multiply by 2, 4 pi a square is the area of a sphere if I calculate through Cartesian coordinate system. This answer probably you will not get anywhere else. Okay. So whatever we have provided, probably it would not be available anywhere else. Okay. So now we can move on to a spherical coordinate system. Spherical coordinate system. So what we have seen, we calculated the surface area we started with Cartesian coordinate system, and then we went with interoperability and we calculated through the polar coordinate system. Next, we stood by Cartesian coordinate system and we calculated the surface area through the Cartesian coordinate itself. Can we do interoperability with a spherical coordinate system? So in a spherical coordinate system, what is a spherical coordinate system? A spherical coordinate system has three variables. One is theta, that is rotating along xy plane. One is theta. One is theta, that is rotating along xy plane. And one is radius a. A is radius of the sphere, and one is angle from the vertical. One is angle in xy plane. If this is vertical, then this is xy plane. One angle along xy plane, that is theta angle, and one angle from the vertical. So theta rotates 2 pi, full 360 degree, and one is from vertical. There is a phi angle, and it rotates full 180 degree, that is phi. So three independent components. One is with vertical, I make phi angle. One is this radius itself, and one is theta, that is rotating in xy plane. Why these three components? Because three are orthogonal to each other. This explanation again, it is not available anywhere else. So if now how it is? If I go with the phi angle, if it is phi angle, then see the arc it is making. It is making arc like this, vertical arc. It is making arc like this. This arc, and now if I am along x-axis, then this is making arc like this. This arc along x-axis and this arc along y-axis, they are orthogonal to each other. If that is the case, now third is radius. If you see radius on xy plane, then it is orthogonal to the horizontal arc. If you take radius in this vertical plane, again it is orthogonal to the vertical arc. So radius is orthogonal to vertical arc, radius is orthogonal to horizontal arc, and vertical arc and horizontal arc are each other's orthogonal. This proves that a spherical coordinate system, all three components are perpendicular to each other. Now let's compute integration a by square root of a square minus x square minus y square d area. D area is nothing but xy plane area. If it is xy plane area, then it is r dr d theta. I'm sorry, r d theta dr. If along the xy plane, if I want to calculate the, if I take dA area, then dA is r d theta dr. Someone can try. So R is, so in a spherical coordinate system, if this is a sphere and it is centered at the origin, then if this is A, if this end is center and this end is at the periphery surface, if I push it inside the ball and it is becomes full radius, then this A and this A makes phi angle with the vertical. So A sine phi is the radius component along the xy plane. A sine phi is not A. So if this is xy plane and this is A making phi angle, when phi angle is 90 degree, then this A is completely radius along the sphere curve on the xy plane. But if it is A making phi degree, any phi, and if this is sine A sine phi, then this is smaller than the actual radius A of the sphere on the xy plane. Okay, so r d theta dr. So r is A sine phi because we are talking about xy plane dA. Integration is double integration or single integration A by square root of A square minus x square minus y square dA. dA is the on the xy plane, on the xy plane. What is dA in a spherical coordinate system? dA is r d theta dr, where r is a sine phi. So a sine phi, dr become a cos phi d phi and d theta. So a sine phi, a cos phi d phi. So a square sine phi cos phi d phi d theta. Okay, and now we have a by square root of a square minus x square minus y square. So x component is a sine phi cos theta. Y component is a sine phi sine theta. That is spherical coordinate system. Please refer to our video on that. We have tons of information we have placed on this coordinate system. So a by square root of a square minus x square minus y square becomes a by square root of a square minus x is now a sine phi cos theta and y is now a sine phi. If this is phi angle, this is radius, a sine phi falls on xy plane. A sine phi cos theta, a sine phi sine theta, x axis, y axis. So theta gone. So it becomes a by square root of a square minus a square sine phi. A comes out and a gone. So 1 by square root of a square root of 1 minus sine square phi. Okay. So that becomes 1 by cos phi into a square sine phi cos phi. Cos phi gone. A square I can keep outside and it becomes sine phi d theta. Sine phi d theta. If that is the case, then integration of sine phi is minus cos phi. Minus cos phi. Minus cos phi. Now phi angle, if I take, okay, if I take 0 to pi by 2, then it will give me top hemisphere. This is what we will do because xy we had calculated in top hemisphere. So minus cos phi, limit is 0 to pi by 2. So cos pi by 2 is 0. Cos 0 is 1. Minus, then minus 1. So it becomes a square. Now d theta integration is theta 0 to 2 pi. So 2 pi a square is the surface area of the top hemisphere. Then it is 4 pi a square. So we calculated through Cartesian coordinate system, Cartesian polar coordinate system interoperability, and Cartesian coordinate system, a spherical coordinate system interoperability. No one will talk this much. Okay, then we will calculate the much awaiting a sphere surface area with respect to the inherit a spherical coordinate system. So that is pending, and these are only, I believe, Cartesian to polar coordinate system interoperability. That solution is available. Otherwise, whatever I am talking, at least I could not find it. If it is available, I could not find it. Okay, so that we will see. Okay, meanwhile, if you are capable, if you are capable, then please support us. It helps us. So please support us.